So today we're going over nomenclature. And nomenclature is just a big fancy word for naming compounds. We're going to learn how to write the names and give formulas for different chemical compounds. There's some different formulas that you need to be aware of. There's molecular formulas, which are exact number of atoms in each element. So like H2O, C6H12O6, or N2H4. And an allotrope is a distinct form of the element. So like O2 and O3, even though they're made up of just the same atoms, they're different. O2 is the oxygen gas. Does anyone know what O3 is? Ozone. Yes. Ozone. And then empirical formulas are the formula that's written in the simplest whole number ratio. So like the molecular formula C6H12O2 would be written as CH6O. That is in the lowest ratio. Wow, what's going on? These are just different ways that molecules can be represented. We'll probably do the first three. We probably won't do space filling models very often. Okay, so writing formulas. You need to write elements with charges. This is looking at ionic compounds. So in ionic compounds, when you're dealing with the ions, you'll probably want to look at your ion sheet. You'll probably want that out today. We'll be using that. You would want to write out the elements that are in the compound with their charges. And then we're going to end up crossing over the charges, but basically you need to balance out the charges. So here, calcium chlorate. Hold on. I must have the... This can't be hidden. Calcium has what charge? A 2+. And then what is ClO3? Chlorate. So ClO3, it's a polyatomic ion, so that would be in the little box above your periodic table. So can everyone find chlorate, ClO3? What charge does it have? -1. So what, how many chlorates do we need to balance out the calcium? 2. We want the charges to balance out. It needs to be a neutral compound. So we have a 2+ and we have a -1. So how many -1s do we need? 2. Crossing over the charges means we're going to cross them over once we are familiar with balancing out charges. It's easy just to see when you cross over the charges. This is why you can cross over charges. But you would write it, now you don't have to write a 1 here, but you'd have ClO3. And we do not want to just put a 2 here, because what does that look like? 32. It looks like 32. It looks like we have 32 oxygens. We don't have 32 oxygens, we have 2 chlorates. We can never change any of the subscripts on the polyatomic ion. So we can't change the 3 to a 2, because that would then be chlorite. It's no longer chlorate. So we need to make sure we leave the subscripts of polyatomic ions alone, but we can put a 2 here, so we have 2 chlorates. So this would be the formula for calcium chlorate. Now if we're given a formula and you want to name the compound, there's a couple different rules that we'll use. Binary compounds, you know what binary would probably mean? 2. So it's formed from 2 elements. You would name the metal cation, and the cation's names do not change. If you look on your ion chart, all the cations names are the same as their ion or as their element name. But then you would follow that by the nonmetallic anion. And in the anion, you'll notice on your ion chart, the INE ending has been dropped and an IDE ending has been added. So like NaCl is sodium chloride, not sodium chlorine. IDE, the INE ending has been dropped and IDE added. Ternary compounds consist of 3 elements, and usually that's dealing with the polyatomic ions, and most of them, the second element is oxygen. So usually we'll have an oxygen in that compound. But it's the cation name followed by the polyatomic ion name. We don't have to do anything with changing endings because the polyatomic name is never changed. You don't ever change that unless it's an acid, which we'll talk about tomorrow. So Na2SO4, you would look up Na is sodium and then SO4 is sulfate. It's not sodium sulfur oxide. Okay. You'll never have 3 element names in the compound name. So if you ever see there's 3 elements, that probably means the cation or the anion is a polyatomic ion. So look up in the chart. Most likely it's an anion because there's only two cations in the polyatomic chart, right? In the bottom right of that little box, there's only 2. So most likely it's going to be the anion portion that's the polyatomic ion. And then transition metals we've talked about have several different ions, iron 3 or iron 2. So you have to determine which type of iron atom it is, and then you would name it using the Roman numerals. How do we know this is iron 3? How do you know it's a +3 charge? It doesn't say +3 in our formula.
There's 3 outside every iron.
So we do know what sulfate is. So if it's Fe2SO4 what charge does sulfate have? Negative. It's not -1. -2. So it's a -2, which means total, if we have 3 sulfates, what's our total negative charge? -6, which means this positive charge must equal -6. And how many ions are there? 2. So each iron must be +3. +3, which is why we use iron 3. That's how we know it's iron 3. Okay. So let's do a bunch of problems here. We're going to name these compounds. What would the name be? Copper. And then we need to look up NO3. Nitrate. Now look at copper on your ion chart. What do you notice about copper? Oh, we need a Roman numeral. Whenever your cation is a transition metal, so if it's like in group 3 and over, you need to probably check to make sure it doesn't need a Roman numeral. Those are the elements that would probably need a Roman numeral. So which copper ion is it? Which copper ion? With the 3? Oh, if it's in group 3 or over, if your element is in group 3 or over, check to make sure it needs Roman numerals. It probably will, because there's probably multiple ions of that form. It's copper 2. How do we know it's copper 2? Right, this is a -1 charge, and we have 2 nitrates, so it's a total of -2. That means copper has to be a +2. So it's copper 2 nitrate. That would be the correct name. But the next one. Do I need Roman numerals? No. Potassium is in group 1. Group 1 and 2 never have Roman numerals. So So it is just potassium phosphate. Ooh, the next one has 4 elements in it. Ah, ammonium. With ClO3. Chlorate. Right. NH4, that's probably the cation, the polyatomic cation that you'll see the most. What is the other one? I don't even know what the other one they list. Hydronium. Yeah, that doesn't form any compound or any compounds. It's its own identity when we deal with acids. So NH4 is your only polyatomic cation. So whenever you see NH4, just recognize that as ammonium. And then chlorate. And ammonium is a +1, so that 3 did not come from the ammonium. Plus, if that was from a 3+ charge, let's say aluminum. So aluminum has a 3+ charge. And then let's say it was ClO3. This would look like let's not say it's 3. Let's say it was perchlorate, sorry. That'll make more sense. So if it was hypochlorite, so aluminum plus hypochlorite, would this be the correct formula for it? No, what do I need to add? Right. Because I don't have 3 oxygens, I have 3 hypochlorites. So if you look at this 3, since there's no parentheses here, you know that 3 is part of the polyatomic ion. How about the next one? Next one's, lead, they say 2 oxide. Do you guys agree? Does everyone agree? Remington says yes. How do you know it's lead 2? Oxygen's -2, which means lead has to be the +2. Good. And then the last one? Thiosulfate? Thiosulfate's S2O2. O3. Sulfite. Okay, so this is why we're going to have ion quizzes so you guys are familiar with those polyatomic ions. You need to be able to, it'll be easier if you can recognize them, not looking them up all the time. It is. So lithium's a +1, and sulfite is SO3 2-. Oops. It does. Because now, how many +1s do we need to balance out the 2-? So we need 2 lithiums to balance out the SO3. Or if you just cross it, you'd bring the 2 over and 1 over. Questions about naming? False. Okay, write formulas. Potassium. Potassium is just K, right? And what charge? Plus. And that's a -1. So we just need 1 of each. Yep. So it would just be, oh, it's nitrite. But the charge stays the same, right? So it'd still be just KNO2. What about magnesium hydroxide? Magnesium is what charge? And hydroxide? It's a -1. So I need 2 hydroxides. So it'd be Mg. Right, we do need parentheses. We have 2 hydroxides, not just 2 hydrogens. Copper chromate. So Cu has a +1. It already tells us what charge it is. What's chromate? What charge? So what would be our... We need 2 coppers, okay. And we have just one of those, so we don't need to put parentheses around it. It's still negative ion, but you don't show the positive or negatives in the compound formula because they're balanced out. As a whole, the compound's neutral. Okay, cadmium sulfate or sulfide. 2+. What's sulfide? S what? Right. Now, the 2+ and 2- balance each other, so we don't even need to write any of the 2's down here. We just have CDS. If you're used to crossing over, it would have looked like this. But you do need to reduce these down to the empirical formula. Okay. And last one here. Calcium is Ca with what charge?
2+.
And phosphate? 3-.
Multiply the first one by 2 and the second, or first one by 3, second one by 2.
Right, we'll get a 6+ and a 6- charge. So it'd be Ca 3, and then PO4 in parentheses, right, 2. Or if you do look and you cross them over, the 2 came over here and the 3 came over here. So we have 3 and a 2. Usually that will work. What's next here? I think we'll stop there for now. So tomorrow we'll finish up.
Is iron test going to be like the element one?
Yep. Yep.
Okay.
Now these will be due not tomorrow. I'm even thinking Monday. Yeah. Because we'll have a lab and everything. We'll make it Friday for now. Put Friday, and then we'll, yeah. You are not. Can I see yours?